Hello everyone, this is Dr. N.Senthil Madasamy, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session.
In this session, topic to be covered is second part of networking devices. At the end of Unit 4, the students will be able to describe the steps involved in investigating network forensics for the attacks. At the end of this session, the students will be able to understand the routers, switches, hub, IDs and firewalls under networking devices. In the previous session, we will discuss about the following networking devices: proxy servers, web servers, PHP servers, SNTP servers, DNS servers. In this session, we are going to discuss following networking devices: routers, switches, hub, IDs and firewalls. Now we are going to see about router, switch and hub. A router is a hardware that connects a network to one or more other networks, one node to another. The router inspects each packet and then that packet based on the IP address contained in each packet. The switch is a data link layer device. The switch can perform error checking before forwarding data, which make it very efficient as it does not forward the packets that have the errors and forward the good packets selectively to the correct port only. Hub connects multiple wires coming from different branches. For example, the connector in the hub cannot filter the data, so the data packets are sent to all connected devices. Currently, most traffic on internet uses IPv4. Internet Protocol version 4 is a fourth version protocol for connectionless data transmission on packet switched internet. A packet is a block of data transmitted across a network. On the internet, these packets are transmitted in sequence, and each packet is uniform in size and structure. An IP packet is the block of data sent across the internet, which contains header section and data section. An IPv4 header has the 14 fields as outlined in the diagram. Version. The version, a value of 4 bits, shows that it is a IPv4. Internet header length, IHL, the length of the header. Differentiated Services Code Point, DSCP. The Differentiated Services TIFF-SERV, code for real-time data congestion notification, ECN. An optional feature that allows for notification of network congestion. Total length, a 16-bit field that denotes the size of the packet, header and data. Identification, a unique identifier. Flag, a unique identifier used to identify the fragments. Fragment offset, a 13-bit value used to specify the offset of a fragment. Time to live, TTL, the time that a datagram may enter decrements its number and discard the packet when it reaches 0. Protocol, the protocol used in the data port of the IP datagram as defined in IANA. Header checksum, used for error checking by the router. Source IP address, the sender's IP address. Destination IP address, the recipient IP address. Options, the frequently used but can hold the data from IHL. IPv4 uses the 32-bit addresses, which are used in 4 octets of dotted decimal notation. See the previous example for the www.pas.edu, where 198.105.44.27 is an IPv4 address. IPv6 is a latest version, like IPv4, was developed by Internet Engineering Task Force, IETF. It was developed in response to the limited number of IP addresses associated with IPv4. 4,294,967,296 available addresses. Internet Authority IANA is responsible for allocation of IP address globally. All devices operating on Internet need an IP address. IPv6 is a 128-bit address and therefore has the 128 addresses available. The example of 198.105.44.27 converts to 2002 C669 2 C1B 0 0 0 in IPv6. As you can see this example, an IPv6 address has 8 groupings of 4 hexadecimal digits and semicolons are used to separate each grouping. NetFlow is a helpful tool for network forensics investigators because it can capture the transaction for IP network traffic. Cisco developed the tool in 1996, but it works with NetFlow compatible routers and switches regardless of manufacturer. Most routers are NetFlow compatible. NetFlow version 9 has become the basis for IETF standard called Internet Protocol Flow Information Export IPFIX. The NetFlow is particularly helpful with instant response because it can potentially capture all connection activity between the nodes on a network. This network flow activity is then forwarded to a collector, a server that captures, processes and saves these transactions. The data stored is an IP, source and destination ports, IP protocol used, and type of service, but not the content of packets saved. NetFlow is a beneficial when full packet capture is not feasible. The intrusion detection system IDS is hardware or software used to monitor network traffic for malicious activity. An IDS can provide alerts when suspicious activity occurs and provide detailed logging information with professional reporting capabilities. An IDS is generally sophisticated system in that can alert the network administrator to anomalies on network related to normal activity instead of simply being pre-programmed. An IDS can work either heuristically or with predetermined signatures. This is important because anomalies differ from network to network. For example, data being transmitted from a government facility in the US or China may trigger an alert, whereas internet traffic between the US university and Beijing may be an everyday occurrence. The IDS monitors the outbound network traffic. Naturally, IDS with its logs and reports is one of the first items a network forensics examiner analysis. The effectiveness of IDS or an intrusion prevention system is diminished by encryption because of system inability to inspect these packets. In such cases, the log from network monitoring tools can be invaluable. FireEye provides one of these tools that check for the malware. Unfortunately, in the case of the target stores, alerts by FireEye were largely ignored and data theft of millions of customers continued after the company was notified. Many different types of IDS exist and they all work in very different ways. Network Intrusion Detection System NIDS, Host-Based Intrusion Detection System HIDS, Intrusion Prevention System IPS. A firewall is a software or hardware mechanism used to inspect the data packets on a network and determine based on its set of rules whether each packet should be allowed through. The network administrator can set these rules. For example, an administrator might prohibit inbound, outbound traffic from IP addresses from China. Chinese hackers have been known to get around this by using Google Chrome for command and control so that they can access network without being flagged by the firewall. Network administrators should add known malware sites to the firewall as blocked websites. These malware sites are published on websites www.malwaredomainlist.com and are also available from federal law enforcement. One of the first things that the hacker may try to do is to change the firewall settings so that they can send and receive the data without interruption. The network forensics examiner will check to see if the firewall rules have been changed. A firewall can be built into an operating system or could be a part of a network router. In the summary, we learned about routers, switches, hubs, IDS, and firewall under networking devices. I mentioned references.
I hope you found this video is clear about the topic I lecture. Thank you and have a pleasant day.